Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to create a bus passenger counter with the help of yolov8. But before we move to our practical friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much and let's get started. So friends, as I mentioned, today we are going to create a bus passenger counter with the help of yolov8. We are going to create our own custom model which detect passenger head, or we can say which detect passenger face. So let's get started. So this is Windows 11 machine. Of course you can use your Windows 10 machine also. So first we are going to install our packages. So just open Python IDE, then go to the tools, manage packages, and search for opencv Python. This is what our first package, opencv Python. Just select it, click on install, and then it will install opencv on our Windows machine. Then we need ultralytics package for yolov8. Click on search on PyPy, then just select the package, click on install, done. It will install ultralytics on our Windows machine. Then we need a CV zone package, so just search for CV zone, select first package CV zone, click on install, and then it will install CV zone on our Windows machine. So we have done with package installation. We install opencv Python, we install ultralytics, we install CV zone on our machine. Done. So for today's session I have created a new repository. I will mention the link. You need to simply copy paste the link inside the browser. Then the repository name is yolov8 object detection for public transport monitoring. Code, click on the code, then go to the download zip, and it will download our zip format repository. As you can see, it's now downloading. So friends, as you can see, we successfully download our repository. So just open download folder. This is what our repository. As you can see, right click, WinRAR, extract with the folder name, and then it will extract our repository. Again same folder, and let's just first watch our video file. So fdoor.avi means the front door of the bus. So if I open the video file, and as you can see, this is the bus, and we have inside bus view with the help of CCTV camera, and bus is now stopped at the station bus stop, and this is the automatic front door, and door is open, and now passenger, or we can say the person, is basically entering inside the bus using this automatic door. So our goal is to detect the passenger head, or we can say their face. Then we are going to mention here region of interest area, because we don't want to detect passenger all in bus. We only want to detect the passenger when the passenger is basically entering inside the bus through this door, through this front door. So our goal is to detect passenger only in this area. This is what our area, as you can see, this is what our area. So our goal is to detect a passenger head or face only this area, because passenger is basically entering from here and then he will go inside the bus. Here it is, as you can see, the ticket machine. So this is what my region of interest area. So here we are going to mention region of interest area, and then as I mentioned, we are going to create our own custom model which detect person head, and then we are going to draw, of course we are going to draw the rectangle with the help of our model, and then we can say if that rectangle center point, if it is inside our area, which we are going to mention as a polyline. So if the person rectangle head, if it is inside our area, then we can simply say this is basically passenger, and we are going to track the passenger. Also with the help of tracker, we are going to assign the unique ID for each passenger, so it is really easy to create a counter. So this is the whole concept which we are going to use for this project. So first, let's just create our own custom object detection model which detect person head for yolov8. So this is what video file. So first we need images. So this is what our video file. Let me start again. As you can see, bus is stopped, door is open, and the person, or we can say the passengers, is basically entering inside the bus. This is what ticket machine, as you can see, ticket machine done, and then they just completely enter inside the bus. So first, as I mentioned, let's just capture images with the help of our img.py code, and this img.py code will capture images with the help of our video file itself. As you can see, the video file name which I have mentioned already inside the code. Then the maximum frames we need for this project, I have mentioned 200. You can simply increase as per your requirement the number. So for this, I have mentioned 200 images is more than enough. Then here cv2.imwrite. cv2.imwrite is basically capture image and save inside the folder. So here we need to mention our folder path. So first, let's just create our folder, new folder inside our repository. So we are now inside our repository. So right click, new folder, and simply mention images, the folder name, images, done. Then right click to the folder, copy as a path, and just open our img.py, and from images, as you can see, from images, just remove all the things, remove it like this way, and then just press Ctrl+V, because we copy our folder path, so it will paste that folder path in our code. And then as you can see, the line which we paste is look like this way, it's look like this way. See, users, username, downloads folder, then our repository name, and again inside that we have same folder, same repository name, and then we have images folder. So now here we need to simply remove this double quote. As you can see, images, after that we have double quote, so just remove it. And then here at the start point we have two double quotes, so we need only one, so just remove one. Then you will see now the line is perfect. Now the line is perfect. That's it. Now here after images you can see the person. So this is basically image name. It can change as per your requirement. This is basically our class name, or we can say this is basically our image name, not basically class name. I have mentioned here image name same as our object which we want to detect. So I have mentioned person. You can mention person head, or you can only mention the head. Simple. So I have mentioned person here, and then this is what our extension .jpg. Simple. So it will capture 200 images because we mentioned 200 maximum frames, and then it will save inside our repository, and inside that we create a new folder which is images, and name of our all images basically person.jpg. Simple. So let's just start our codes, just save it, and let's just run the code. Now it started our video file, it's capturing images, and then when it complete 200 images, it will automatically turn off our video file. So now if I open our images folder which we just create inside our repository, and inside that, as you can see, we have 199 images. As you can see, this is the last one, person199.jpg. So we capture 199 images with the help of our video file. Simple. So we have done with images. Now we are going to simply use these images for labeling purpose. So for labeling purpose, we need label img software. So label img is basically work with Python 3.8 version. So we need Python 3.8. So how to install Python 3.8? Simple. Just open Microsoft Store. As you can see, Microsoft Store. Just open it, and here we are going to search for Python. So it will basically show all the Python version which available. So as you can see, I have mentioned just Python, and we have all the versions: Python 3.11, 3.10, 3.9, 3.7, and 3.8. So for label img we need Python 3.8. So just click on the Python 3.8 version, and then you will see the install button. Just click on install button, that's it, done. It will install Python 3.8. As you can see, if I click here, I have already installed Python 3.8 on my Windows machine. So it is really easy. Just open Microsoft Store, search for Python and then Python 3.8. Click on install, it will install Python 3.8. Now we have done with Python 3.8 installation. So now we need to change the version for our Thony Python IDE. So just go to the run, configure interpreter, and then here, as you can see here, just click on, and then it will pop up the window like this way. So we need to select here our version which we just installed, the Python 3.8. So as you can see, the line is look like this way. This is the path of the folder, Python 3.8 exe, users, feed, app data, local, Microsoft, Windows app, and Python 3.8. Just select it, click on OK, and inside shell, as you can see, the version is now changed. Now we are working on Python 3.8 version. Done. So now simply we need to install label.img. So it is really easy. Just go to the tools, manage packages, and search for label.img. Label.img. Then just hit enter. It will search label.img package. First package, click on install, done. It will install label.img. That's it, we have done with label.img. Now simply go to the tools again, open system shell, and here we need to run our label.img command. So just run label.img. As you can see, this is what our command, label.img. Done. Now just hit enter. It will open our label.img software like this way. Now simply we need to select our dir. So we need to select OpenDIR as our images folder. So go to the downloads, our repository where we create our images folder, just select the folder. And then as you can see, we have our all images. Then change save dir, again same folder, repository, again same folder, and images folder, just click on select folder. Done. So this is how you need to install label.img. Also you need to select OpenDIR and change save dir folder. Simple. Now friends, as I mentioned, what is our goal? Our goal is to detect passenger head, or we can say passenger face. But in this first image, as you can see, there is no passenger is basically entering inside the bus, because the door is, the front door is still closed, it's not open. So for that, we are going to simply skip all those images where our object is not there. Means in this scenario, our object is person head, or we can say the passenger head. So in this image, there is no passenger, means there is no passenger head. So we are going to simply skip those images where our object is not there. So just click on next image, next image, next image, next, just go next, because still there is no passenger. Go next. Now door is open, but we cannot see the passenger head or face. Just go next. Just go for next image, next, and then now as you can see, we can see their face. As I mentioned, in 49 image, we can simply see the passenger face. So now just create a rectangle box and draw a rectangle box and mention our class name, which is person. Click on OK, click on save. Now this is how you need to draw rectangle on each passenger face. Simple. So now just go for next, create a rectangle, click on OK, save it, just go for next image, draw rectangle box, click on OK, save it, go for next image, create rectangle box, draw the rectangle box, click on OK, save it. Now let me draw a rectangle box on each passenger face. After that, I will start video again. So friends, I have done with drawing rectangle with the help of label.img on their head, on the passenger head or face. As you can see, this is the last image. Actually we mentioned 200 images, but as I mentioned, we skip some images because in some images there is no object, means there is no person, and in some images our passenger is cross our region of interest area. So now there is no need to draw a rectangle box on their face or head if the person is basically cross our region of interest area. So 132 image number, as you can see 132 image number here, this is what the last passenger, and he is completely enter inside the bus, and he is, as I mentioned, this is what my region of interest area, all this is. So this person is also already cross the region of interest area. So now after these images, let me save first, and after these images, as you can see, the person is completely enter inside the bus. So now there is no need to draw a rectangle box on their face or the head, because person is completely enter inside the bus. So we are going to create our model which only detect a person head or face when the person is entering inside the bus, not when he is completely enter inside the bus. Simple. For that we are going to skip all those images where the person is basically completely inside the bus. Simple. So now because we skip some images here, so we need to delete those images. So I have done with label img, I have explained the full code. Also when we implement our model, then you will get a better idea how our model will work. Simple. So let's just close our label img because we have done with label img. Now close the system shell, and then now simply we need to again change our version. So just go to the run configure interpreter and select the default version, the first version Python, click on OK, and now Python 3.10.11. Now as I mentioned, I have created a code which basically delete images. So go to the open, downloads, our repository, and img delete yolo8. This is the code, as I mentioned, this is the code which basically check image and their text file, If you open our repository and where we create our images folder, inside that, as you can see, we have txt file and we have images. So it means label img is basically create image and their text file, So inside that text file we have rectangle coordinates. So now simply our img delete, just a minute, okay, now it's good. So our img delete yolo8 code will search if the image is there and if the text file is there. If it is not there text file, it will delete all those images. Simple. So let's just, because I have mentioned here images folder, image directory, here you need to mention the folder where you have all our images and their text file. So I have mentioned images folder because we create our images folder inside our same repository. So images folder. Now simply run the code, and as you can see, it's printed the number images deleted person47.jpg because person47.txt does not exist. It basically print all the images number, and because person5.txt does not exist, person6.jpg is deleted because person6.txt does not exist. So this is how it basically delete all those images which don't have .txt file. Simple. So now we have done with our labeling process. Now simply just minimize Sony Python ID, again go to the repository, same folder, and now we have our images. Now here we are going to create a new folder, and the name of folder is basically Freedom Tech. So right click and new folder, images, and oh sorry, not images, the folder name is Freedom Tech. Freedom Tech is the folder name. Done. Now just go inside the Freedom Tech folder, and here again we are going to create two new folder, images and labels. So right click, new, images and labels, we are now inside freedom tech folder, and inside freedom tech folder we create again two new folder, which is images and labels. Now just select one of the folder. So let's just select images folder and go inside images folder, and here now we are going to create again two new folder. First one is training and next one is validation. So training and validation. Training and validation. Now same way inside labels, training and validation. New folder, training, and new folder, validation. That's it. So this is how we create freedom tech folder. Then we create images and labels folder. Now just go inside images folder, create a validation and training folder, and same way go inside labels folder, create training and validation folder. Now simply go back, and from images where we have all our data, just press Ctrl+A, select all the data, then copy it, and then go back, go to the freedom tech, images, training, just paste it. Then go back, then validation, just paste it. Then go back, then go labels, validation, just paste it. Then go back, just training and paste it. So we copy paste our all data from images folder to freedom tech, images, training and validation, as you can see. Then go back and then freedom tech, labels, training and validation folder. Copy paste all the data from our images folder. So done. Now simply we are going to create our freedom tech folder as a zip file. So right click, WinRAR, add to archive.zip, click on OK. It will create freedomtech.zip file, as you can see. Now simply we are going to upload our file on our Google Drive. So I have opened my Google Drive, right click, file upload, and then go to the downloads, our repository, and then freedomtech.zip, select it, click on open. Now it will upload our file. Meanwhile simply we are going to upload our collab file. So upload, click on browse, downloads, our repository name, and this is what our Google Colab file, which I have mentioned inside our repository. So now it's uploading our Colab file on our Google Colab. So friends, as you can see, we have successfully uploaded our Colab file. Now simply go to the runtime, change runtime type, select Python 3, then select T4 GPU, click on save. Done. Now simply click on connect, it will connect. So friends, as you can see, we successfully connected. Now simply we are going to run our cell one by one. So let's just start with first cell, then second cell. It will install ultralytics. So friends, we have done with installing ultralytics. Now simply we are going to call our ultralytics. As you can see, from ultralytics import yolo, also from ipython.display import display and image. Then we are going to cross check if our ultralytics is perfectly installed. So we are going to simply use image from roboflow.com, and the image name is dog.jpeg. It will detect our objects from the images and it will save the result inside runs, detect and predict. So if there is error, of course it will not detect any object. So if the result is there, it will save the result and is detected the object. And as you can see, there is a person, there is one person, there is a one car, and there is one dog in particular dog.jpeg image, and the result is basically saved inside runs, detect, predict. It means our ultralytics we successfully install on our Colab machine. Now simply we are going to mount our Google Drive, because we upload our freedomtech.zip on our Google Drive and one upload completed. So we successfully upload our freedomtech.zip. Now simply we need to mount our Google Drive. So just run this one code from google.colab import drive, connect to Google Drive, select it, the Gmail ID, click on continue, scroll down, click on allow. Now it will mount our Google Drive. Done. As you can see, we have our freedomtech.zip. Now simply click on the next cell, it will create a dataset directory, and inside that it will mention, or it will just copy freedomtech.zip, and then it will unzip all freedomtech.zip file. So as you can see, inside that we have person and their text file and their images, as simple as. Now just click on this folder icon, then go to the dataset folder. As you can see, we create here a dataset folder, so just click on here on the dataset, and inside that we have freedom tech folder. So now select these three dots, and then create a new file and mention the new file name data.yaml, simple, and then just hit enter. It will create data.yaml file. Then double click to the data.yaml file, it will open data.yaml file. Right now it's completely empty, there is nothing. So we need to copy our code inside data.yaml. So code which I have mentioned inside our repository, data.txt file. So just open with text editor. This is just a normal text file. So copy the code, copy it, close the file, and just paste inside data.yaml file. Right click and paste it. Done. Now here number of classes is basically 1, because right now we are going to only train one class, which is person, and the names only mention your class name. So in this case we have person. Simple. Then press Ctrl+S, it will save our data.yaml file. We have done. Now we are ready, and then run last cell. It will start 100 epochs, and it will create our own model. And friends, as you can see, it started our epoch process 1 and out of 100. So it will take some time. Meanwhile, I will pause video. So friends, as you can see, our process is completed and we have successfully created our model. And our model is basically saved inside runs, detect, and train folder. So this one is the runs folder, selected. Then inside that we have detect folder, selected, and inside that we have train folder. As you can see, train, selected, and then inside train folder we have weights folder, and inside weights we have best.pt, our own model. So just select it, click on download, and it will download our best.pt model. So friends, as you can see, we successfully download our model. So minimize all these things, open download folder, and inside that we have our best.pt. So right click, cut, and move our model inside our repository where we have our all files. So now simply here we need to create a coco1.txt, our own class file. So just right click, coco.txt, so text document, coco1.txt, open it and mention the class name person, simple, and just save it. Now just open test.py, and inside that I have mentioned a full code. So let's just delete all our other Python code file, and then edit and clear shell. Now friends, if you don't know how to use yolov8 with Python, opencv, and our tracker, so I have already created a playlist. Watch the playlist and then you will get the idea how to use yolov8 and tracker, object detection, and all other things. So I have already mentioned the code for this project. So we are going to simply overview what basically inside our code. So this is what our modules: cv2, pandas as pd, ultralytics and cvzone, numpy as np, tracker, import tracker, and then we have our model, base.pt is our model name. Then this is what our mouse event function, which we are going to use for selecting our region of interest area. Then tracker is equal to tracker. This is how we call our tracker file. So tracker file is basically inside our repository. And then video file, then coco1.txt file, our class name file, which we just create. And then we have our detection, and then we have our rectangle class name, and then we are going to append the list, because if we want to use our tracker, we need to send our rectangle coordinates, the object rectangle coordinates, to our tracker, and then create a new rectangle coordinate. So we need to use all the rectangle coordinates along with their ID. So for bbox, in bbox idx tracker dot update list, as I mentioned, I have explained how to use tracker in deep way in my previous video. So you need to first watch my playlist, then you will get the idea. So here we send the list. As you can see, we send the list. Here we create a list, and inside that we mention our x1, y1, x2, y2 object rectangle coordinates, and then we mention a list, and then we call a list inside our tracker.update, and then now tracker will get the coordinates, and again it will create a new coordinates. So x3, y3, x4, y4, and the ID for each object. Then cx and cy, because we need a center point, so cx and cy is basically int x3 plus x4 divided by 2, y3 plus y4 divided by 2. That's it. Now let's just first draw a rectangle with the help of our tracker coordinates. So here it is, I have mentioned x3, y3, x4 and y4, and then because we have ID, so we are going to simply use here cvs on put text method, and we are going to put our ID as a text on x3 and y3, means the rectangle top left corner. And then here let's just freeze our frame. If I save the code, if I run the code, and as you can see, we started our video file. Because we freeze our frame, so we need to skip our video file one by one. So let's just press a space button from keyboard. Now we are skipping a frame by frame. So now door is open. As I mentioned, we create our model which only detect when the passenger is basically entering from the door. Right now there is no passenger is basically entering from the door, so there is no detection, there is no object detection. So when we see the passenger face, and as you can see, now there is a rectangle. Now there is a rectangle on passenger face, because we create a model which we want to work like this way. When there is a passenger, then only we need to detect their face, or we can say their head. So now as you can see, this passenger is basically entering inside our bus, and we can clearly see their face. In that time there is a rectangle on their face, means our model is perfectly working, is detecting our object. As you can see, done. So this passenger is basically already crossed our area. So ID is still there 1. So watch for the second passenger, ID is still there 2. And this passenger is also crossed our area. Now watch for this passenger, is coming inside our bus, done. As you can see, he crossed our area, then there is no detection, because we train our images like this way with the help of label img. As I mentioned, when we create our model, then you will get the idea. So this is, as I mentioned, this is what my region of interest area. Only in this area we need to detect the person head, or we can say their face. So we create our model like this way, which only detect the person head in this particular area. As simple as. Now let's just, what we are going to do, let's just start a while loop again, and now let's just watch. The door is open, there is no detection, there is no object detection. But when we see a passenger face, there is detection 1, 2 ID for this person, this passenger, the second passenger, then 3 ID for this passenger, and then 4 ID for this passenger. So we can simply detect the passenger when the passenger is basically entering inside our bus. Okay, so now what we are going to do here, I have already mentioned the region of interest area. I have already mentioned the region of interest area. Now simply if I start the code again, let me make here 0. What we are going to do, we are going to simply change our area coordinates. Simple. So we are going to change our area coordinates. Let's just say, let me skip here some more frames because still there is no per passenger. And as you can see, now we can see the passenger face. So here we are going to draw a circle, and let me mention here, instead of drawing full rectangle, on their face, we are going to use here cv zone dot corner rect method. cv zone dot corner rect method. I have mentioned the method already inside the code. So this cv zone dot corner rect method will basically create pink color rectangle, and their corner is highlighted with green color. So for that we need x3 and y3. So we have x3 and y3, and then we need width and height. So w and h is basically x4 minus x3, and y4 minus y3. Then we will get the width and height, and then we can simply use this method. As you can see, cv zone corner r capital rect frame, we are going to draw a rectangle on our frame, x3 and y3, and w and h this coordinate, and the 10 and the 5, this is the size. So now if I save the code and if I run the code, now we will see a pink color rectangle, also the corner is highlighted with green color. So let me skip here frame. And as you can see, as I mentioned, there is a pink color rectangle and the corner is basically highlighted with green color. Simple. So now we are ready, and as I mentioned, we need to mention our region of interest area. So for that, again, let's just draw a center point. So we mention our cx and cy, so now it will draw a center point. So we have started our frame, there is no passenger. So as you can see, now there is a center point. And here, let's just say here we need to draw our polyline. So if I go here and inside shell, because we mention our mouse event function, as I already explained here, let me mention here. As you can see, this is what our mouse event function. So when we move our mouse cursor on our frame, inside shell we have coordinates. So we are going to simply use those coordinates. So let's just go over here, and if I move my mouse cursor over here, so for this we have 716 272, 716 just a minute, 71627 here, 715273, 715273, 715,273. That's it. Now, so we mention here our first point. So if I go here and inside shell we have 688272, 688272, 688 272 is basically here. Then if we go here, 712487, 712487, 712 487, 712,487, and the last point, let's just say over here, 783,484, 783,484, 783,484. Done. So this is what our area 1 coordinates. I have changed the coordinates. So now simply if we run our cv2.polylines coordinate frame np.array and area 1, this is what a new coordinates which we just mentioned. This is what our new coordinates which we just mentioned with the help of mouse event function. Now it will draw a polylines using our area 1 coordinates on the frame. And as you can see, so this is our coordinates. So let's just make like this way. Here 734,486, 734,486, 734,486. Let me cross check because we need to make it perfect, so it will come here. This is the point. 737,487, 737,487. This one. 737,487. You can simply change the coordinates. First, let's just draw a polylines with the coordinates, then you can change the coordinates for looking perfect, the polyline area. So now it's look perfect. As you can see, it's perfect. Now if I skip here a frame one by one, and now as you can see, the person center point is inside our area, and for this the second passenger also, as you can see, it's inside our area, the center point. And then for this passenger, let's just assume that okay, now the center point is basically inside our area. And then for this passenger, let's just check, yes, it's inside our area and still inside our area. So we successfully mentioned our area. Now second area, what we are going to do, simply we are going to use this polyline, and inside that again we are going to use a second polyline. So let's just say I need to only mention here, let's just take this coordinate, this one. So what we are going to do, we start from here. So this is what this is the second polyline. So for second polyline, my starting point is this, let's just say this one. So 701,272, 701,272, 701,272, 701,272, simple. 701,272. So we mention here 701,272, and then this is what our next point. So this next point is basically we are going to use from our polyline 1 area. So this is what my polyline 1 area first point, this is what my polyline area second point. So the second polyline which we want to draw right now, so we are going to use a same coordinates for drawing second polyline area second point. Our first polyline second point is same point for drawing second polyline second point. So the area 2 point, the second point is basically 688 and 272, 688 and 272, because we are going to use a same polyline. So this is what for polyline 2, this is what my first point, and the second point of polyline 2 means the area 2 is same as our area 1, same as our area 1. So we need to mention our second point. Done here. Now we done with second point. Now this is what our third point, which is also same as our area 1 third point, area 1 third point. So let's just mention here same point 737,487, and the last point which we are going to use here, the middle, 758,486, 758,486, 758,486. So if I save the code, if I run the code, oh, we forget to mention our polyline method. So this is what my area 2. For area 2, we need to again mention our polyline method, and here I have mentioned area 2. Save the code, run the code. If there is something issue, we can simply change, but there is no issue. As you can see, there is no issue. We mention both area. So this is what my first area we can say, and this is what my second area. This is what my first area, area 1, and this is what my second area. So we have done with both area. We draw a polyline with the help of our area coordinates. Now simply we can mention our condition. So let's just again skip our frame one by one. The door will open and then passenger will enter inside the bus. So right now there is no passenger, so there is no detection, nothing is there. When we can see their face, there is a rectangle, there is a center point, there is a ID for each passenger, and the first passenger is center point is now enter inside our first area, then enter inside our second area. So we successfully mentioned our area. Now we are ready and we are going to use our CV2 point polygon test method. So here CV2 dot point P capital polygon T capital test, CV2 point polygon test T capital, and then we need to mention our both areas. So let's just start with our first area, copy it and then mention as it is. This is what our area method. So just copy it and mention as it is inside CV2 dot point polygon test method, and then we need to mention their center point coordinates. So center point coordinate is basically Cx and Cy. So mention in tuple format, and then after that mention false, and then the result of this method is basically 1 or -1. So if result, if it is greater than or is equal to 0, then only we are going to draw a rectangle, then only we are going to draw a circle, then only we are going to put our text. Save the code, run the code. We start our frame and then we are going to skip our frame because we want to check our result frame by frame. That's why we have mentioned a 0. We freeze our frame and we are skipping a frame step by step for our knowing purpose. So now as you can see, the person is basically enter inside the bus, but there is no detection because we mentioned if the person center point, if the person rectangle center point, if it is inside our area 1, then only draw a rectangle, then only put the ID. So right now the person rectangle center point is not inside our area. When the person, as you can see, there is a center point, it's inside our area, and then we can see there is a rectangle, and then as you can see it's inside our second area, but there is nothing. Simple. So now for our knowing purpose we can simply cross check for our second area also. So let's just copy the code as it is and mention over here and just paste it, and here let's just check if it is in line, otherwise it will create a error. So it's in line, and then here we are going to mention this as a result 1. Here also we are going to mention result 1, and then we are going to mention this as a area 2. And because our knowing purpose, when the center point inside our area 2, we are going to change the rectangle color. So rectangle, or let's just change, because we use a corner rectangle method, so we are going to change their center point color. So here I have mentioned blue, so let's just mention pink. If the center point, if it is inside second area, it will become pink. If it is inside area 1, it will become blue. Here it is, as you can see. Save the code, run the code. So skip the frame. And then there is a person, and when the person enter inside our area 1, the color is blue center point, and then when same center point inside area 2, as you can see, the center point color is changed. Now it's become a pink. It's become a pink. Let's just watch for second passenger. It's blue, then it's pink. Watch for third passenger. It's blue, then it's pink. Done. So now what we are going to do, we can simply create our condition. If the person, if it is inside our area 1, the person center point means the rectangle center point, if it is inside our area 1, we are going to save their ID and their current position inside the dictionary, and the dictionary name is pin. Pin means the person in. Simple. So let's just mention, this is what our first condition. If result, if it is greater than or is equal to 0, means the person is basically entering inside area 1, then we are going to mention pin is our dictionary, which we mention over here. Here it is, pin is our dictionary, and then pin, and then we are going to save their current ID and is equal to their current position. So their current position is basically their center point. So Cx and Cy. That's it, done. Now if you print over here, if you print, let's just say here, if you print here pin, which is our dictionary, inside that dictionary we are going to save their ID and their current position when the person center point, if it is inside our area 1. So frame is started, and I am skipping frame one by one. And as you can see, right now the dictionary is empty, there is nothing. But when the person center point inside our area 1, as I mentioned, we are saving their ID and their current position. So now inside dictionary, as you can see, their ID 1 and their center point 739356. So this is for first person. Now then the second person, area 1, it is inside our area 1, and inside dictionary, as you can see, their ID 2 and their current position. Simple. So this is how our method will work. Now simply we can say, now we know that our person is basically crossing our area 1 because we are saving their ID and their current position. So we have now their unique ID. So we can simply say the same person, because we have their unique ID for each person. So we can simply say same ID is now crossing our area 2, because we know that this ID is already crossed my area 1. Now the same ID is crossed my area 2, because we are saving their ID and their current position inside pin dictionary. So we are going to call our ID from that dictionary, and we can simply mention now only detect those ID which already part of my first area. Simple. So here we mention pin ID. After that we can simply mention like this way: if ID inside our pin dictionary, so if ID in pin, then we are going to mention our second condition. So copy it and then just paste it, or let's just, because we mention here our area 2, so let's just remove all these things, because when person center point, if it is inside area 1, we only want to save their ID and their current position. There is no need to draw a rectangle and other things. So we are only saving their ID and their current position when the person center point inside our area 1. So if it is greater than is equal to 1, this is for area 1, then we are saving their ID, and then we are going to create our new condition. If the ID inside our pin, means if the person is already part of our area 1, then we are going to simply mention our result 1 condition, which is same person ID is now crossing our area 2. So same method, cv2.pointPolygon test method, mention the area 2. So copy just area 2 and mention cx and cy, and then same way, if result 1, if it is greater than or is equal to 0, then we are going to draw all these things. Done. Save the code. Now let's just start our while loop. Save it and run it. So we started our while loop. So person is entering inside our, as you can see, there is only pink color circle, not rectangle, pink color circle, because we mentioned only draw all these things when the same ID is basically crossing area 1 and same ID is now entering inside our area 2, and inside the dictionary, as you can see, we are saving their ID. Done. We have successfully detect our object, we are successfully tracking our object. Now last and important thing, we need to count. So simply because we have their ID, so ID is basically unique for each person. So we are going to simply create a list of ID, and then we are going to mention the length of ID, the list of length of ID. So here we mention our all the condition. So after that, simply mention, because I have mentioned here a list, and the list name is basically enter. Simple. So enter dot append after all our condition match. This is what our first condition, then we are saving their ID and their current position. Then we mention if the ID inside our pin dictionary, then we are going to say that only count or only detect those ID which already part of our area 1, because we know that ID is already part of area 1 because we are saving their ID. Then we are going to mention our second condition for area 2, then we are going to draw and all other things. So after that, enter append, and what we are going to append? We are going to append their ID. So now, because the person will take some time for crossing our area 1 to area 2, so we need to mention here our condition. Meanwhile, basically it will count a same ID again and again, because it will take some time to crossing our area 1 to area 2. So for that we need to mention here a condition. If enter dot count, and what we are counting? We are counting their ID. If is equal to 0 means please don't count same ID again and again, and then we are going to append their list. Now we mention here list already there, list file. Now if we go here and if we print length of our enter list, now this is the number, of a passenger counter, enter, save it, and if I run, because we mentioned our while loop, so now we can count the how many passenger is basically entering inside the bus using front door. So right now, as you can see, there is a 0, no count yet, 0. So when first passenger coming inside, we detected, and as you can see, there is 1, then there is 2, we count 2 passenger, then there is a 3, as you can see, there is a 3, and then there is a 4. So we successfully count 4 passenger. Now simply we need to mention this counter on our frame. So we can simply use here our cvzone put text method. So let's just mention cvzone put text method, and now we need to mention this counter over here, and then let's just mention as a variable. So like this way, let's just say EP entering person. So I have mentioned just EP as a variable. You can mention any variable as per your idea. So EP length enter, and then cvzone put text method. Here I need to mention count as a variable, count, or let's just say counter, like this way. and then we are going to mention our counter, which is EP. That's it. And then what else we want? We need to mention the coordinates. So 50, 60, 50 and 60, and then let's just say 2 is the rectangle size and 2 is the text size. Save the code, run the code, and as you can see there is a counter. So right now 0. So when the passenger is basically enter, we mention our condition, we mention our area. When it's match our condition, we have counter 1, we count 1 passenger, 2, we count 2 passenger, then third one 3, and then fourth one. So friends, as you can see, this is how, friends, you can use yolov8. You can create your own custom object detection model, and you can simply create smart bus passenger counter. I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.